If you're looking for the ultimate complete overview of EC2 auto scaling groups, you're in the right spot. We'll be covering what auto scaling groups are, the different features and options available, and how you can benefit from them. After the video, if you want to dive in deeper on this topic or learn more AWS services, check out our great training options on cloudvikings.io. Let's dive in. Welcome back. It's time to dive into EC2 auto scaling groups. Now, we had these auto scaling groups, or ASGs, pop up in a few of our lesson discussions already, but let's take a further look at these in isolation to dive a bit deeper. Now, we've learned about the flexibility benefits of the AWS cloud, especially with the EC2 service. We can deploy thousands of servers in a matter of minutes to adjust to growing workload demands, and we can just as easily terminate those instances when they're not needed to save costs. But when you're at that scale of needing hundreds or thousands of EC2 instances, spread across tens or perhaps hundreds of different application workloads in an organization, you can imagine having to keep track of all these instances and just the sheer effort involved with manually keeping an eye on your workload performance metrics, and then having to adjust the amount of instances up and down all the time to keep that ideal balance, of maintaining your minimum performance levels for your application to keep your workload healthy, but not having excess EC2 instances where their capacity is just not adding any value, and it's just extra resources and, again, extra costs involved. This is where auto-scaling groups swoop in to save the day. Auto-scaling groups act like the accordion for your capacity needs. It's the instrument that helps scale out by adding more EC2 instances to keep up with the growing load demands, or, scale back in by terminating these EC2 instances to match, the decrease in load demands for your applications. The auto-scaling groups are one of the main tools that AWS customers can use to help save on compute costs in the cloud. They can help ensure you're running at the optimal compute capacity all the time and not spending money on wasted resources just sitting idle. This is also a huge differentiator compared to the traditional IT days with our own physical data centers. This concept of auto-scaling is simply not possible with the same type of speed and flexibility offered here. With data centers, you need to buy and operate enough server capacity for that peak load demand, and it may take, weeks or months to scale out for increased capacity needs. Then if, that demand decreases, you're stuck with potentially hundreds of expensive servers sitting there doing nothing but making heat. There's a tremendous amount of OpEx tied up with this traditional IT approach, and the capacity planning game always ends up being a losing battle. You're rushing to play catch up with increased demands, and you want to avoid that situation again, so you add some buffer to your next server order. So then you have that breathing room in case that load increases even further. And then you either repeat the cycle over and over, or if that demand decreases, you're sitting on tons of expensive servers, adding no value to the business. So let's talk about some of the core functions of these auto-scaling groups known as ASGs. First, they let us define the type of instances within the ASG. We can essentially tell the ASG the details of what servers need to be there for our workload, like what type of instance types they need to be. We basically define the cookie cutter shape, and the ASG stamps out more of the same cookies as needed, or again, eats them to get rid of them. Now, another important feature is the auto recovery capabilities an ASG provides. If we have one of our instances or a number of them go offline for whatever reason, the ASG will automatically trigger the launch of new instances to replace them. How cool is that? Seriously. So if something happens on the AWS side and the physical server that our EC2 virtual machine instance runs on, has some type of issue and our instance becomes unavailable, or if we have some type of application level crash within our software running on it, the ASGs can replace these servers very quickly to maintain that optimal capacity level we desire. Then these ASGs give us some options on how we want to scale our capacity within these groups. We can say that I want full control over the scaling operations of my EC2 resources and pick a manual scaling option here. We trade off the automated scale in and scale out benefits of an ASG, but in turn we have full control over this activity. Even with this full manual approach, we still get the auto recovery benefits of ASGs. Now, we can also use some dynamic scaling options to automate that scaling process for us. Now, there's also a scheduled scaling option that can add or decrease capacity based on a certain time and different days of the week. Now, this is helpful if we have a fairly stable demand curve at different times of the day. We can use scheduled scaling to proactively scale out our compute capacity to meet the expected demand so that our instances are all launched and ready to serve traffic just prior to the demand increase. Now, we can also leverage something called target tracking. As an example, let's keep it simple and pick our instance CPU utilization as our metric of interest. With this target tracking, we can say we want to keep our CPU level at perhaps 70% as an example to make good use of our instance's capacity and keep our application workload healthy. With this target tracking method, the ASG will average out the CPU utilization of the entire ASG group and scale it in or out to keep the average around that 70% mark. Now, if we have a sudden load increase and our average CPU hits 78%, the ASG may add 3 more instances to the group to help balance the load better and get the overall average on all the instances to 70% again. We define that target, that 70% CPU utilization in our example, and the ASG will dynamically add or remove capacity to keep things as close as possible to that target metric as it can. Now, again, we used CPU here for the example, but the target metric can be really any type of custom host or application level performance metric that's the best reflection of demand for your workload in these instances. Then there are simple and step scaling options. Now, there's a lot of configuration variations possible within these options, but the idea is that we define the scaling action behavior and thresholds here. Now, between simple scaling and step scaling is the more modern option to pick. The idea with step scaling is that you define scaling step adjustments based on, the metric that you define. When that actual value of that metric hits one of our thresholds, the ASG scales out by a predefined amount. So as an example, if we were, 10% over our metric value, we may want to add 2 instances to our ASG. But if we're 20% over, we may want to take a more aggressive step here to quickly address the load change. So we'll perhaps add 6 instances. Now, if we're 30% over, maybe we add 10 instances. And the same applies for scaling back in. We can configure the logic of how the ASG shrinks back down again. Now, target tracking is the easier choice, but again, we don't have that control over the scaling behavior. By default, it will try to scale out as fast as it can to keep the ASG load at your target metric value, and then it takes a bit more conservative scale-in approach to bring things back down again. If you know your workload and traffic patterns very well, and they're somewhat predictable, and you also have those well-defined and tested scaling metric values, the step scaling approach can have its advantages where you can more finely tune the scaling behavior to maximize your cost savings. However, you may find that the target tracking approach is reliable enough for your needs, and it's a million times better than having to scale in and out manually each time. Now, yet another option I'll mention quickly here is the predictive scaling option. To me, this is like a more intelligent scheduled scaling method. What this predictive scaling option does here is use our historical load data that AWS captures in a service called CloudWatch, and then does a machine learning-based analysis of this data. It essentially uses our past load data and makes a statistical best guess of what our load will be at a given point in time. Now, the more consistent our traffic patterns are over the course of multiple days or weeks or months, the more accurate the predictions this option can make for us. So the benefit here is that instead of us having to do that guessing ourselves and set up predefined auto-scaling events to add capacity at certain times of the day, we can now rely on the AWS machine learning models to use our historical data and make these often much more accurate scaling decisions for us. Now, we have all these EC2 instances being added or removed from our ASG to handle some type of workload traffic. But how does the client side, basically that requesting side trying to user service, know about this additional capacity, or what happens when the ASG scales in? This is often where we'd want to use the power of an elastic load balancer for a central endpoint for our service. The ASG would then contain all our EC2 capacity that would handle these requests. The beautiful thing with using an ELB along with the ASG is that you can simply attach your ASG to the ELB through the configuration options, and then the instances in the ASG automatically register and deregister themselves from the ELB. So in a scale-out scenario, say 10 new instances get added to our ASG, those 10 new instances will automatically be registered with the ELB, basically saying, hey, look at me, give me some work to do. And the ELB will start directing some of that incoming traffic to those new hosts. Now, like most AWS services and features, there's a lot more to discover here. There's a lot of configuration options available to us to tune all these target metric values for our workload. the scaling behaviors of the ASG, and how the ELB and ASG interact with each other through health checks and other options. But I'll stop here for this ASG overview lesson. But you should have a good understanding now of the purpose and power of these auto-scaling groups, especially when used in combination with the elastic load balancer to build highly resilient, self-healing, and flexible compute resources for AWS workloads. See you in the next lesson.